has ended, or I sorry, the live stream has ended, so we can repeat what I'm about to say. All right, so for today's topic, good morning, everybody. Good morning. All right, so for
Good
today's
morning, sir.
topic, yeah,
Sir, wala pa po.
wala pa.
Wala pa po. Ayan, meron na.
Ayan na. All right, so hopefully the internet connection is stable as it was a couple of minutes ago. But yeah, uh, let's talk about the Enterobacteriaceae family. So Enterobacteriaceae family is of course your gram negative is the gram negative one, and a lot of questions are going to come from this family. Would you believe it or not? A couple of students in I think which school was that? Um, Baguio, somewhere in Baguio. I'm not sure which one. Xavier University or something. St. Louis University said that they did a study about the Enterobacteriaceae family, and what they found out is that a lot of the questions in the board exam, yes, a lot of the questions in the board exam came from this family. That's why I dedicated a specific slideshow for this one. Okay, now let's talk about general characteristics first. These are questions that are commonly asked in the board exam. So I want you guys to be familiarized with them. Try to let them marinate in your noggin as much as possible because first thing that you're going to talk about is the motility. All right, all members of the Enterobacteriaceae family are motile except for the following. Take note of the first two: Klebsiella, Shigella, the Salmonella species Salmonella polorum, and Salmonella gallinarum. All right? Okay? So please take note of them. Also, highlight Shigella species because this is what you call the innate bacillus. What do you mean by innate bacillus? Innately negative bacillus. All of the tests that you're going to do for the species of Enterobacteriaceae will test negative for Shigella. All right. So motility. What else? Sulfide and indole and Volks Pro scour will test negative for your Shigella species. Okay. The only thing that you will notice about Shigella is that it's the only one aside from Salmonella that will grow on enteric medium, such as your SSA and Hectoin enteric medium. All right. Now let's move on. I hope everybody remembers these three families, these three organisms, four organisms rather, and three families. I separated Salmonella polorum and Salmonella gallinarum for you guys to be familiar because these two organisms here are the only Salmonella species that aren't motile. All right, now let's talk about the oxygen preferences of the Enterobacteriaceae family. All of them are facultative anaerobes. Okay, when you say facultative anaerobes, they can survive in O2 environment, and that is one characteristic of them that that separates them from the other gram-negative organisms. Organisms such as Pseudomonas will not grow in the absence of oxygen. All right, you'll find out later because we've discussed in last week's lecture. We've discussed about the oxidase activity. It said that any organism that produces oxidase is mostly, rather, I would say mostly, the correct terminology would be mostly, because without the oxygen, they will not be able to utilize they will not be able to utilize, to function as normal as it should. Okay? So all Enterobacteriaceae family, okay, are facultative anaerobes. Next, all members of Enterobacteriaceae can ferment what sugar? Glucose. All right? They can ferment glucose. And the members of the Enterobacteriaceae family can actually be classified with another sugar fermentation test, which is your lactose fermentation. Okay, they can be classified as either late lactose fermenter, early lactose fermenter, or non-lactose fermenter. And you're going to see that later on when we talk about them one by one. All right? So all members of Enterobacteriaceae can ferment what sugar? Glucose. But Enterobacteriaceae family can also be classified. On the other hand, it can also be another sugar, sorry, in addition, Another sugar classification test, or can be Enterobacteriaceae family can be classified with lactose fermentation as well. All right, so there's two things that you can talk about. There's two sugars, but there's a lot of sugar testing medium that we're going to talk about later on. But mainly, this is the general characteristic that we need to talk about here right now. All right. Now, all members of the Enterobacteriaceae family are catalase pass positive, except for what? Shigella dysenteriae. All right, Shigella dysenteriae or Shigella dysenteriae, Shigella species in general. All right, because we're not gonna talk about the non-pathologic Shigella anyway. So just write Shigella species. Okay. Now, I want to ask a review from last week's lecture. Anybody from the class can can anybody from the class tell me what is the reagent used for catalase test? Anybody? What reagent can we use for catalase test? Anybody? This is a must-know question. Catalase test. Anybody? All right, somebody raise their hand. Anna Jemima Athing.
Sir,
Please.
hydrogen peroxide po.
Wonderful, wonderful. Thank you so much. But what percentage of hydrogen peroxide? I want you to be specific because there's superoxole test. Remember? All right, Francis, thank you. Can you please answer for me?
3% hydrogen peroxide, sir.
Wonderful. Thank you so much. So I guess people are studying from last week's lecture. So thank you so much. All right, now, what test is used to differentiate Vibrionaceae from the Enterobacteriaceae family? Remember that I've told you guys before that the Enterobacteriaceae family are facultative anaerobes, and therefore another test that is used to differentiate them from the other species of gram-negative organisms, such as the Vibrionaceae family, is your oxidase test. Enterobacteriaceae family will test negative, while the Vibrionaceae family will test positive. All right? Pseudomonaceae will also test positive for that one because they are obligate aerobes. But there are some species that are a little bit weird reacting, and we're gonna talk about them later on. We're just jotting down some of the general characteristics, just for you guys to get a little bit of warm up. Now, all members of the Enterobacteriaceae family reduces nitrates to nitrites except for what species? The entero, the entero, the Erwinia species. And we're going to talk about one specific species here, Pantoea agglomerans. It was originally classified as Erwinia agglomerans, and then it became Enterobacter agglomerans, and now the term is Erwinia herbicola. I will type it in the I will type it in the chat. I do not know if it will be asked in the board exams for you, but the the current name of Pantoea agglomerans is now Erwinia Erwinia herbicola. O, 'di ba? Updated pa rin si Sir. Ang galing, no? Updated pa rin ako. I started making these flashcards in the year 2009, and it's still useful to some of the students who are taking the board exam, the Philippine board exam and the ACP board exams. Hopefully you guys will be able to utilize the material that has been presented in front of you. It's okay. Now, antigenic structures associated with the family Enterobacteriaceae. You have your you have your what? There's several antigenic structures that you need to talk about. The OHK antigens. All right, so OHK antigens basically stand for, this is the answer to this question, the second bullet, the location of each antigen in the bacterial cell is your O antigen is the somatic antigen, while the H antigen is the flagellar antigen, and K is for capsular. All right. Somatic. That's why I capitalized O, so that you guys will remember. And then the K antigen, capsular. All right. You will find this out later, especially when we talk about the Salmonella species, specifically the Salmonella, Salmonella typhi family, the one that causes typhoid fever. All right. The antigens are especially useful in the bacterial serology of salmonellosis. All right. Okay. Now, antigenic structures in the Enterobacteriaceae family that are considered heat labile and heat stable. Let's talk about the K and O antigen. Actually, both both capsular and some and both capsular and flagellar are considered to be heat labile, and the only heat stable antigenic structure is your O antigen. But some books still speculate. Some books, especially the one that they use in the Philippines, Bailey's and Scott's. Oftentimes they don't write the flagellar antigens because it depends on the organism. Remember that each organism has a different each bacteria or each family or genera of bacteria has a different structure of has a different orientation, or rather structure of or layout, right? Let's just call it layout of how of their flagella. One could be monotrichous, then the other organism can be peritricous, and the other one can be amphitricous, and so on and so forth. So uh, that the heat stability of these antigens differ or vary depending on the layout of the organism's structure. So K antigen is the safest answer, mainly because we're using in the Philippines we're using Bailey's and Scott's. I'm not sure when what is the latest edition of Bailey's and Scott's, but um in my preparation for the board exam, I think it was the 19th edition. See? Okay, so every year they try to update it, and hopefully for you guys it's still the 19th edition when you take the board exam. Now let's move on to VI antigen. VI antigen is referred to as what antigenic structure? It is actually the cell wall antigen, and it's specifically important for the family Vibrio sorry, Salmonellaceae, or Salmonella, sorry, Salmonella. So ano naman si Salmonella? It's basically your Salmonella species. All right? Okay? So it's present in some Salmonella or Salmonella species. Napaka-arte kasi, sir, bakit kailangan pang Salmonella? Pinaarte ko lang. Huwag kayo masyadong ma-intimidate dun sa mga terminologies na ginagamit. Kasi this is the type of language that will make you different from other healthcare professionals, because some of them are not familiar with these terminologies, and I want you guys to be above the rest. O, di ba? Ang bait-bait ni sir. Gusto niya maging above the rest, pero ang dami niyang pinapaalala sa amin. Alright, so flagellar structures are usually denatured by two things. It is either through the use of alcohols or through heat. Okay? And let's talk about the immunoglobulins for a while. Um, in order for us to get a better understanding of the antigenic structure of your bacteria, you need to understand also the immunoglobulins that attaches to some of the antigens. So for the O antigen or the somatic antigen, it is predominantly the IgM, the IgM, what do you call this? The IgM class. All right, for the flagellar antigen, because it's way smaller uh, than the than the somatic antigen. It's therefore postulated that the predominant immunoglobulin is IgG. All right. So because of the size, IgM will not be able to form lattice formation, and therefore many of the scientists believe that it's predominantly IgG. Okay, remember the cell itself is the somatic antigen, the whole cell itself, while the flagella is a tiny bit, a tiny portion of the bacterium, and therefore it is important for you guys to remember the predominant antigen because of this because of this because of this of this slide. All right, now let's talk about biochemical testing and culture. Let's start first with culture because you only need to know one slide for that. Most commonly used culture media for the Enterobacteriaceae family. I know there's more, and we're gonna discuss them as we talk about the organisms one by one. But our generally we use four. My clue for you guys is Shem. What's Shem? Salmonella Shigella agar, Hectowin enteric agar, Eosin methylene blue, and Makonki agar. Each of them um, have different inhibitors. All right. But the most commonly asked question here is for Makonki and Eosin methylene blue. Now, do you guys remember the inhibitory substance that is added in Makonki agar? Anybody? Can anybody can anybody remember the inhibitor substance that prevents the growth of gram-positive organism in Makonki agar? Review from last week's lecture. Anybody? Hello? Hello? What makes Makonki agar a differential slash selective medium? This is due to crystal violet. Thank you so much. All right, wonderful, wonderful. Crystal violet. Dapat sure. Next time, Charis, dapat sure ha. Charis ha. Hoy, Charis. Wala pa silang energy.
Yes, sir.
Wala pa. Kakatapos lang ba ng lunch? Grabe kayo. Ako kakagising ko pa nga. Ay, kakagising. Kakauwi ko pa lang eh. Kayo talaga. From waking up and then going to the hospital and then troubleshooting the machine and then going back again. I made it a point to appear to you guys. Charing! Taray no. Alright. Now let's move on to TSI. TSI. Can somebody transcribe TSI for me? It's the easiest one.
Triple sugar iron.
All right, triple sugar iron agar. See ya sometimes. Triple sugar iron. All right, so there's three sugars that are present inside. Okay, the components are basically the general components of TSI is sugars, color indicator, and the H2S indicator. So sugars, we have three, of course. First one is your glucose. All right. Second one is lactose. Third one is sucrose. Okay, 1%, 1%, 0.1%. 0.1% is what? Glucose. Don't remember. You can't remember everything. 1% for 1% sugar except for glucose. 0.1% for glucose. All right. Why is there 0.1% glucose? Because it will help you differentiate, because all members of the Enterobacteriaceae family can ferment glucose, and therefore if that's small, if and therefore of we don't want a lot of glucose in the medium. All right, color indicator again is phenol red, and the H2O sorry, tongue twister. H2S indicator is the sodium thiosulfate or thiosulfate. All right, sodium thiosulfate. Okay, these are the components. Okay, 1% sucrose, 1% lactose, 0.1% glucose. Color indicator is phenol red. H2S indicator is thiosulfate. All right. Cool, cool beans. All right, let's move on. The reaction of TSI is actually a funny one. All right, let's go to the next slide. The first one is that the thiosulfate is present in the medium. Because the organism produces hydrogen sulfide, the sulfide molecules will then separate from sulfur, so will then separate to sulfate ions to sulfate ions, and the remaining the ferrostate iron will bind to form ferric sulfide. All right, so that's what basically happens in the reaction. Ironically, what happens is the sulfate ions remain outside, but it is actually the iron from the microorganisms that bind bind to the hydrogen sulfide molecules. All right, cool. Easy. So sodium thiosulfate. So thiosulfate, sulfide molecules will have hydrogen sulfide and sulfate ions. Sulfate ions. The sulfate ions will be left out of the reaction, and the hydrogen sulfide molecules will then bind to the iron in the ferrous state produced by the microorganisms to produce what you call ferric sulfide. That ferric sulfide is the black one or the black substance that you see in your culture medium. All right. Now, let's talk about Leah. Can anybody transcribe Leah for me? Oh, it's not the name of a girl. All right. What is Leah? Anybody?
Lysine, iron, agar.
All right. Wonderful. So the people here still remember their third year microbiology class, and that is a wonderful thing because all you need to do is just review on what it is. So the color indicator is bromcresol purple. Bromcresol purple. And bromcresol purple has two color reactions. But we'll talk about that later. We'll talk about the components first. The next one is the H2S indicator. The H2S indicator for lysine iron agar is actually ferric ammonium citrate. All right, ferric ammonium citrate. H2S indicator. Similar reaction, okay? Only this time, only this time, ferric molecules from the H2S indicator will actually bind. One molecule of iron will bind to the H2S in the to the iron produced by the microorganisms to form your H2S. Okay? So I don't need to elaborate long more on the reaction because they're usually not going to be asked in the board exam. But a reaction will be the only difference is that hydrogen sulfide is not present. Hydrogen sulfide the will not come from the base chemical. It will actually be a the H2S indicator acts here as a ion atom donor. Okay, biochemistry. This is advanced chemistry for us medical technologists. So we're not gonna delve deeper into that. Okay, because the only question for you guys that is important here is the color indicator and the H2S indicator, and you guys have a lot of things to remember. All right. Now, metabolic action that is detected by Leah is actually two things. It's either deamination or decarboxylation. And what portion of the media would each metabolic pathway be detected? Deamination is detected in the slant, all right? And decarboxylation is detected in the butt. What do I mean by the slant and the butt? Quick review for you guys. I'll make a pen here. I'll make a drawing for you guys. Oops. I want I need a different color. Let me change the color for a while. Okay, so they said the agar is purple, so we're gonna use purple. I don't know if it looks purple there in your screens, but we have the slant and the butt. So deamination is detected here. All right, that is the slant. The butt is this one. All right. Just imagine this is a this is a correctly formed test tube. So deamination is detected in the slant, decarboxylation is detected in the butt. All right? So butt means puwet, kumbaga. All right? Now, Next, let's move on to tryptophanase enzyme. So the detection of tryptophanase enzyme is tested with indole test. And the media that we use it for, there's two media actually that we use it for. Peptone broth or SIM. What is SIM? Anybody from our lovely participants? What is SIM? Hello? You can unmute yourself or you can just type the results for me. You can even Google the results. I'm that chill. Charing. Anybody? Oh, Francis.
Sir, sulfur indole motility, sir.
All right, wonderful. Sulfide, not sulfur, huh? Sulfide.
Sorry, sir.
Careful, careful of the words. But that is, but the last two letters is actually correct. All right. Now the reagents that we used for sulfide indole motility is as follows. It's either the Kovacs reagent or the Ehrlich reagent. And the positive result is a red ring. Okay, so what is the indicator that is used in the test? The indicator used for indole motility is a long one, but they used, I will type it in the chat. This is the acronym PADMA. Does anybody know what PADMA is? Because this was a question in one of the board exam question. This is actually a board exam question in one I think I'm not sure if it's mine or no, 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 it's not. It wasn't mine. It was a friend of mine. It was a classmate of mine who took the exam way earlier than I did. Paradimethylamino del benzaldehyde po. May question mark na naman, hindi sure. Patay tayo dyan. Alright, so I want you to be sure. But that is the correct answer, Joanna. Alright? Mahirap pumunta ng exam nang hindi sure ang sagot, ha? Mahirap ang Mahirap pumunta ng exam. Remember, dapat sure tayo. Patay tayo dyan. Pero yes, that's correct. Yes, Sir Marco, no? Ang galing-galing. Ang galing-galing, no? Kompleto talaga. Meron pa yung dash. Actually, I would have accepted kahit wala yung dash, pero she did herself extra credit. She added the dash. But she could have just written P dimethyl also, but she went the extra mile for the whole class. Diba taray ni Joanna Baltar? I love it. Now let's move on na. So that's the correct answer. Paradimethyl aminobenzaldehyde. Right, correct. That is Padma. That's the one that produces. That's the one that is that's the one that is present in the Kovacs reagent and the Ehrlich reagent. So bakit ang Kovacs lang ang spelling? Bakit Kovacs? Ang arte kasi ng mga nagturo sa akin, sabi nila Kovacs daw ang tamang basa. And the Ehrlich reagent actually daw siya. But we're Filipino, so it doesn't matter. For memorization din pa din. Yes, a lot of the questions in microbiology are not just I think 80% memorization. Yeah, so you have to love microbiology in order for you guys to pass the exam. I suggest I suggest right now, um try your best to look at some of the flashcards or try your best to look at your notes on a daily basis or even put it on a piece of post-it note and then paste it on your walls because come board exam time you're going to thank yourself for doing extra work. All right. It's not like blood banking. In blood banking, you need to have an analytical mind or an imaginative mind. Here in microbiology, you have to have an eidetic memory. Kumbaga. All right? So mag-memory plus gold tayo. All right. Now let's look at the MRVP. What do we mean by MRVP? Another test na naman, sir. Sumasakit na ang ulo namin. What is MRVP? Francis, ikaw naman yung sagot ng sagot ng mga ng mga
Methyl red Vogus proscour po.
All
Vogus
right.
proscour.
Wonderful. Okay. Okay, so it's methyl red Volks Proscour. All right. Just remember it's VP test. if you want to give yourself a little bit of a break, it's just BP test. All right, this is the test used to identify the organism based on the neutralization effects of the microbe. So it is actually methyl red test, and it involves several acids. It measures the acids, resistance to several acids, or rather, it tests the organism's resistance or the resistance to the neutralizing effects of the buffer of the acid buffer. It's either lactic acid, acetic acid, formic acid, or succinic acid. So these are the acids that are tested by methyl red. Okay, next. What is detected by Voges Pro scour? It's the acetoin producing organisms. All right. What is the other name for acetoin? It is acetyl methylcarbinol. All right. And the reagent that we use is the alpha naphthol. Okay. Positive result is of course a red color again. I wasn't able to write the positive result. No, no. I was able to write it, but it's colored differently. Wait, let me try and put a highlight on it so you guys can see it. Because I think I have a different color of notes than you guys. Am I correct? I think I have a different color of notes.
Yes po, sir.
Blue ata dyan sa inyo, sky blue ata sa inyo. Yun yung
Yes
unedited.
po.
Green po, sir.
Oo.
Blue-green.
Yun
Blue-green.
yung unofficial version and the walang trademark yan. Charik. Walang trademark. So yan yung unofficial version. But it's the same thing. I think some slides were just removed because of the uh, because of the what do you call this? I think yeah, I think I removed one slide. I think I removed slide 5 because it was inaccurate to the current meta. Meta talaga to the current what do you call this? To the current to the current knowledge or scientific knowledge that we have right now. All right, so what are the most members of the Enterobacteriaceae family have what results in their MRVP test? This actually most of them will have an opposite result. All right, they will have opposite results. So if methyl red is positive, most of them will test positive, but not all of them, huh? Most of them will test negative for Vogue's Pro Scour, and that occurs vice versa. If methyl red is negative, then automatically Vogue's Pro Scour is going to be positive. So please put that in mind. Okay, most of them. Okay, why did I say most of them? Because in the book you're going to see a lot of if you actually took the time to read your books, you're going to see most of the medically important microorganisms, most of the medically important members of the Enterobacteriaceae family have opposing results in their MRVP test. All right, there are some of them that that have the same results, but they are not considered medically important. So I didn't. So that's the reason why I added this slide for you guys. All right. So next, citrate utilization is carried out in what medium? It is carried out in your Simon citrate agar or the SCA. And can anybody tell me what is the color indicator of the agar?
From time blue po.
From thymol blue. Adrian, since you've answered that question, I want you to unmute yourself and answer me this question. What is the
Yes,
color
sir.
of what is the initial color of the um uninoculated Simon citrate agar?
Blue po.
Blue. All right, let's go on to another person. What about Charis? What is the color of the uninoculated or slash non-reactive base color of your Simon citrate agar? Binabago-bago ko lang yung terms. What is the color of Simon citrate agar that has not been inoculated and there's no organism that has reacted to the color indicator? Anybody? Ana Jemima, what's the color of your base medium that hasn't reacted that hasn't reacted with bromthymol blue?
Green po, sir.
Wonderful. Thank you so much. It's supposed to be green, right? It turns blue when there's citrate utilization. All right. There's a lot because why did I ask this question? Because it was a question that was asked in your in one of my exams. I think it was in my pre-board exams in MCU. Okay. By the way, guys, I am an alumnus from MCU. All right, Manila Central University, Caloocan. All right, I'm an alumnus of that one. All right, now let's move on to the results, the basic results. Why do I need you guys to remember this? Because why did I ask that previous question? It was aside from being asked in my previous exam, because you need to remember the appearance of the citrate medium in the press in your you need to remember the appearance based on the reaction. So in an acidic environment, it's going to turn yellow. Neutral, it's going to turn green. Alkaline, which is what we want to see for citrate utilization, is blue. All right. So, sir, is it okay to get yellow color? Is it positive for citrate? No. This means that the organism has turned the is not utilizing the citrate, but rather it's producing acids. Okay? What we want to look for is the change in color from green to blue. All right? This is the one that we're looking for. So that's the reason why I asked you guys what's the appearance of Simon citrate agar. Okay? Now, malonate utilization is another one, although rarely done in the clinical laboratory, but malonate utilization is going to have a positive blue color, and the negative result is green or yellow. I just added it there. I wanted to remove it, but because it's lacking it's lacking so many details like what reagent do we use. But eh, when I searched for it in the internet, it's just going to have malonate, and then the color indicator is like bromcresol purple as well. But it depends on the manufacturer of the malonate utilization kit that you're using. All right. Okay, so these are the colors. Positive color will be blue, and the negative color is green for malonate utilization. I wish I remove this, but it's still there. Anyway, urease test is another one. Urea urease test is another one. It's a media. There's two culture media that we use for urease, and that's the Christensen's urea agar or cha or kuwa, sorry, kuwa or chua, the Christensen's urea agar, and then we also have Stewart's medium, Stewart's urea broth or sub in some books. Okay, the color indicator is still the same for both. It's phenol red. All right. Christensen's urea agar or kuwa, and then Stewart's urea broth or sub. Okay. So the indicator is phenol red. Okay. Next, indicate the reaction of a urease producing organism. So in this particular wait, what happened to the slideshow? Uh, why is it like that? Wait, let me cancel this slideshow. We are at slide number 57. Discard. We're at slide number 57. I'm gonna drag this out for you guys so you guys can better appreciate the this one. All right. The next one is what happened. All right, so I'm gonna add click title na lang here. Am I being heard? Can you guys hear me? Can you guys hear me? All right, thank you. All right, so urea reacts like this. Urea will be reacted upon by urease, thus separating ammonia and CO2. The ammonia is what's going to be reacted by your phenol red reagent, and therefore it will produce a red positive result. This is it is also an alkali. It is also alkaline, and that's the reason why, it's going to turn red. Okay, CO2 will be left as a gas, basically. Now, let's go to the examples of rapid urease producers. Examples of organisms that are rapid urease producers, we have Proteus species, Providentia, and Morganella. Actually, these three organisms are going to be discussed together. So I want you guys to compartmentalize the knowledge or the information that you're going to learn from this lecture, because there are some organisms that I grouped together based on the general characteristics that they share. All right. So how is a rapid urease producer classified? Well, rapid urease producers are classified in a way that they produce a positive result within 2 to 4 hours after inoculation and incubation. All right. So please remember that there are three organisms that are rapid urease producers: Proteus mirabilis, Proteus species, Providentia, and Morganella. Give me one organism that is a medically important Providentia species, because we already know Proteus mirabilis and Proteus vulgaris. What about for Providentia? Because later on we're going to discuss them, and I want you guys to remember them by heart at the end of the lecture. Or by heart talaga. Give me one. Providentia species. That's the only one that we're going to discuss today. All right, Providentia redgeri. The other one, Morganella morgani, for Morganella species. Okay. So thank you, because not many students know Providential species. All right, now we're going to go with slow urease producers, and they are classified based on a positive result uh, released after 4 hours of inoculation and incubation. So there's only four organisms that you're going to remember. There's only five organisms that you need to remember, and my clue includes your C keys. What's C keys, sir? Hirap naman. C stands for Citrobacter, K stands for Klebsiella, E stands for Enterobacter, Y stands for Yersinia, and last is Serratia. All right. And what are the organisms that we're going to talk about for Citrobacter in this particular lecture? We're going to talk about Citrobacter frundi. Okay. Klebsiella pneumoniae, Oxytoca and Rhinoscleromatis. But Rhinoscleromatis will be interesting for you because that's going to be a different organism now. Enterobacter coloaceae. We also have Yersinia pestis and Serratia marcescens. All right, these are the organisms that we're going to talk about in this lecture. All right. Now, let's go on with ONPG. Oh my gosh. No, it's not OMG. It's ONPG. All right, it detects the enzyme beta galactosidase, and it is used to identify the organisms biochemically as a late lactose fermenter. All right, ONPG test. Connected. Hello? Sorry, I got disconnected. Bumalik na naman yung sakit ng computer, ay ng headphones ko. And I discovered the problem why. I think the problem is the I'm speaking in front of you guys in the Zoom, in the Google Class, and then I also have to live stream it. And I actually corrected it, but it came back again. So apologies for that one. Please remind me in the chat or just raise your hand suddenly if I suddenly lose the microphone or lose any sound. All right? Will that be okay, everybody? Please remind me, huh, if I lose sound. All right. Now, let's move on to orthonitrophenol. ONPG is transcribed as orthonitrophenol beta pyranoside. Ugh, it's such a long thing to remember. It's such a long thing to remember. Chemical orthonitrophenol beta galactopyranoside. The positive result is yellow, and the negative result is colorless because it's a colorless reagent. All right. Now indicate the end products of the following decarboxylation test. So where are we going to find decarboxylation? What media are we going to use when we want to identify if the organism, or we want to see if the organism or the unknown organism that you have has uh, can do decarboxylation of amino acids? What media? Mentioned it earlier before. Can anybody remember? What media? Lia po. Yes, thank you so much, Rona. Now, can I call you Rona? Feeling close, eh, no? All right. FC lang. All right. Now, Rona, where do we see the carboxylation in Lia? Slant or the butt? All right. Butt. Sapwat, sir. Sapwat. All right. So the end products of lysine, ornithine, and arginine, or what you call or our shortcut is LOA, is that it will produce the following. Lysine will produce cadaverine, ornithine will produce putrescine, and arginine will also produce putrescine. All right, and eh, and if you're not familiar with the names of these things, lysine actually is the amino acid. Lysine, the end product of lysine, which is cadaverine, makes the culture media smell like dead bodies. Putrescine is, I think, a name. I was searching for the origins of each of the following names. I can't find putrescine in English, but there were some Spanish translation. I think this is one of the reasons why we have the word putragues, because of this one, because of the smell. All right, because there's a Spanish translation. There were Spanish scientists, I think, who named this one as such. All right, so yeah. Anyway, please don't. The reason why I told it is not because I just wanted to swear, but because I want you guys to remember. All right, so ornithine and arginine produces putrescine, while cadaverine is the end product from lysine deamination, a decarboxylation rather. All right. Now, indicator used for decarboxylase test is from crescent purple again, as I mentioned before. Positive result will be either yellow, purple, yellow. Okay. What do I mean by yellow, purple, yellow? Purple, yellow, purple. Sorry. What do I mean by purple, yellow, purple? There's a purple but there's a purple slant, a yellow butt, and at the very end, you will see a small button of unreacted unreacted agar. That's the reason why. So I will draw it for you guys, so you guys don't so you guys will be able to understand. This is the media. It will be purple, okay? And then on the butt side, it will have the amination here, decarboxylation rather, and it will be yellow. This one will be yellow. All right. And then there's a small piece of culture media that hasn't reacted, and it will be here. Okay. And they're all going to be in a test tube. And just imagine this is a test tube that actually looks like a test tube, not like a not like Turon. Okay, it looks like turon for me or shawarma because I'm getting hungry now. But anyway, let's go to phenylalanine deamination. We use ferric chloride. That's the reason why we have ferric chloride in the LIA test. Okay, phenylalanine deamination, and the color indicator that sorry, the amount of phenylalanine in the reagent is actually the reagent inside it is 10% ferric chloride, and the positive result is a green slant and fluid accumulation. All right. Okay. Hi. What happened? I oops. I accidentally closed my slideshow. Sorry. All right. So that's the appearance of that one. All right. Now let's move on to gelatin liquefaction. Another biochemical test for your Enterobacteriaceae family, specifically for the which test is most common member of the Enterobacteriaceae family that will test positive for this is the Serratia species. Okay, so it's important for the Serratia species. Which one specifically? We have Serratia marcescens and Serratia rubrum. Um, we're going to talk about them later on. So just remember that in gelatin liquefaction, gelatin media is liquefied into amino acids. All right? Really, sir? I thought gelatin has only carbohydrates. No, it's actually gelatin is actually the denatured denatured proteins, and they will form a jelly. Hence the term gelatin. All right. And the next one that we're going to talk about now is we're going to move on with the Escherichia species or the family of Escherichia. But before we move on, I need you guys to give me a 10-minute break. Is that all right with you guys? Or you guys want to move on? 10 minutes is enough for me? Would it be okay? Adrian, is it okay? I didn't hear. Sorry. It was Oh, okay. Thank you so much, Adrian, for being wonderful. All right. So I'm going to end the live stream for now. Um Yeah, because we're gonna move on with Escherichia later, or and the specific microorganisms in the Enterobacteriaceae family.